All right, now let's look at multiplication of two matrices. Here we are to multiply matrix A and B. So to multiply two matrices, um, but then I think first of all let's look at the 2 by 2 matrix. To multiply two matrices, what we are going to do is we are going to multiply the rows by the column. See how this arrow is going, rows by column, where this row, the whole of this row will multiply the whole of this column, right? Then in the next row, the whole of this row will multiply the whole of this column. So let's look at that right away. Now if I'm to multiply this element, this first element is going to multiply this first element here, so which means I'm going to be having CD to be equal to 1 times minus 1, which is minus 1. Then I'm going to be adding that to 2 times 2, which is 4. Now look at this row multiplying this column, right? So the next thing I'm going to do now is this row multiplying this column. Now that is the next step. So where I'm going to have 1 times 0, which is 0, right? Then 2 times minus 3, which is going to be minus 6. So that is what I have there. So I'm going to the next one now, which is this last row. Now this last row is going to multiply this column and this column respectively. So let's do that. 3 times 1 is minus 3, right? Plus 4 times 2, which is what, 8. Then we'll go to the next column. 3 times 0 is 0, right? Plus 4 times 3 is 12, right? But then there's minus, so that is minus 12. So what are we going to have here? We're going to have 3 minus 6, 5 minus 12. So this is our answer for this multiplication. So let's look at AB now. Let's look at AB, that is multiplying these two matrices. This is going to be a bit longer since it is a 3 by 3 matrix. So for here, what we are going to have is the same way, this row to column multiplication, where you are going to have 1 times 0, 1 times 1 is 1. Then that is going to be plus, right, plus 3 times 2. 3 times minus 2 is minus 6, right? Then plus 2 times 8, which is 16, right? So let's move to the next column now. It's going to be this multiplying this middle column now, this first row multiplying this middle column now, which is going to be 1 times 0, which is 0, plus 3 times 5, which is 15, plus 2 times 1, which is what, which is 2. So in the last row you are going to, in the last column you are going to have in 1 times 2, which is 2, plus 3 times 6, which is 18, plus 2 times 0, which is 0, right? So let's go here. This one now is going to multiply this and this. So 1 times 1 now, you're going to be having 1 still, right? Then 0 times minus 2, that is 0. Then 1 times 8, that is plus 8. So the next column now will be 1 times 0, which is 0, plus 0 times 5, which is 0, plus 1 times 1, which is 1. In the last column you are going to have 1 times 2, which is 2, plus 0 times 6, which is 0, plus 1 times 0, which is 0. So let's look at this now. This will multiply this, this, and this. So 1 times 1 is still 1, right? Then minus 2 times minus 2, now we're going to have plus 4, right? Then minus 1 times 8, we're going to have minus 8, right? Then the next column you are going to have 0 plus, that is minus instead, since we have minus 2 here. We're going to have minus 10, that is minus 2 times 5. Then we are going to have minus 1 times 1, which is minus 1, right? Then in the last column we are going to have 1 times 2, which is 2. Then we have minus 12, and we have plus 0. So what is our final answer? Let me use a different pen. So our final answer here is going to be 1 minus 6 plus 16, which is what? Which is 11. Then what else? We are going to have 0 plus 15 plus 2, which is what? 17, right? Then we have 2 plus 18 plus 0, which is what? 20. Then let's look at 1 plus 8. This is 9. This is 1 here. And this is what? This is 2 here. 2 plus 0 plus 0. Then we have this 1 plus 4 minus 8, which is minus 3. Alright. Then we have 0 minus 10 minus 1, which is minus 11. Then we have 2 minus 12, which is minus 10. So this is our multiplication. So quickly, I would like us to look at some basic facts about things you should note about our multiplication. So the first thing I would like you to note about multiplication of two matrices is that two matrices can be multiplied together even if they are not of the same dimension, but the column of matrix 1 must be equal to the rows of matrix 2. For instance, matrix A have dimension m is m by n. That means matrix B must have dimension of n times m, right? The row of this must be the same dimension with the column. So let's look at a typical example. If we have matrix A, what this is saying is that if we have matrix A to be 1, 2, 3, 4, it means for matrix A to be able to multiply matrix B, then B has to be 1, 2, right? These two matrices can multiply each other, where the same number of columns here, 1, 2, is equal to the same number of rows, 1, 2. So these two matrices can multiply each other. And if you want to multiply these two matrices, AB is going to be equal to, let's bring this one here, 1, 2. So if I bring this one here, it should be this times this. I'm going to have 1 plus this times this, I'm going to have 4, right? Then this times this, I'm going to have 3 plus this times this, I'm going to have 8. So this matrix will be what? 5 and 11. So this is called a column matrix, right? This is called a column matrix. We have what is called column matrix. When we go to special matrix, which is in our next video, we are going to be discussing more of that. So let's look at some other interesting properties of multiplication of matrices. The result of the multiplication, called the product matrix, is another matrix with the same number of rows as the first matrix and the same number of columns as the second matrix. So if we look at what we have here, they say the result of the multiplication, called the product, is the matrix with the same number of rows as the first matrix. This is the first matrix here, right? The first matrix has two rows, 1 2. So if you check now, the result also has two rows, 1 2, right? And then it also says the same number of columns as the second matrix. The second matrix has one column. You see it's only one column, but then two rows, 1 2. It also has, the result has two rows, and then it has one column, and the second matrix also have only one column. So let's look at the third property here. It says that multiplication of matrices is not commutative, unlike the normal arithmetic where AB is the same thing as BA. For instance, if you say 2 times 3 is the same thing as 3 times 2, right? Where A is 2 and B is 3, which is equal to 6. But in matrices, if you say CD is not the same thing as DC, right? I'm not going to be doing this. You do this on your own, solve this on your own, and compare. It's going to be amazing to see that is how it's going to be. So, but then there's another interesting thing here: the fact that the multiplication of matrices is associative. The multiplication of matrices is not commutative, but it's associative, where you have A multiplying B multiplying C is equal to A multiplying B multiplying C. So these two properties, I'm going to leave you to go to do them on your own, but then they are very, very interesting to find out. If you multiply A and B and multiply by matrix C, it's the same thing as saying you multiply B and C then multiply by A. So that is that. I hope you like this video. Please like this video and share it with your friends as well, and don't forget to subscribe to this YouTube channel and turn on the notification bell to get notified each time we upload a video. Thank you.